talk a little bit about molarity. Molarity is one way to measure the concentration of a solution. Right? Molarity is moles of a solute over volume of a solution in liters. And the molarity is used a lot in AP Chem, and it's usually how we figure out how many moles we have. And in honors chem, we don't do a lot with solution stoichiometry, but one of the things that we need to be aware of is that if we want to figure out moles, which is generally the key when we're doing stoichiometry, we get there by multiplying molarity times liters. Okay, so as we mentioned, we can use molarity in stoichiometry calculations. So just like we have always, we've been going from grams to moles, and from atoms to moles, and from volume to moles, we can also go from molarity. So if we have a solution and we know its molarity, we can use molarity times liters to give us moles. So here's an example of a molarity problem. Alright, so what volume of 0.5 molar sodium sulfate will completely react with 500 milliliters of 0.2 molar barium chloride? So let's just write the balanced equation first. It's always a good first step. Plus barium chloride, it's going to give us sodium chloride. We'll have two of those, plus barium sulfate. Okay, and what we want to know is the volume of 0.5 molar. Okay, that's going to react with this amount of barium chloride. So I'm going to take that 500 milliliters of barium chloride. Whoops. And what I know is, because it's 0.2 molar, I know 1,000 milliliters, which is a liter, is 0.200 moles of barium chloride, right? And what I know is for every 1 mole of barium chloride, I have 1 mole of sodium sulfate. Okay? And because I want 0.5 molar sodium sulfate, what I know is I want 0.500 moles of sodium sulfate per 1 liter of sodium sulfate. Okay? When I do my plug in my jug, liters, 0.200 liters of sodium sulfate. Okay, so that's how we would use molarity in a stoich problem. Let's take a look at this exercise. We have a diagram on the right, represents an aqueous solution of one of the following compounds: magnesium chloride, potassium chloride, or potassium sulfate. Alright, so what we're going to look for is we've got, first of all, we have a positive 1 ion, which means it can't be magnesium, it's going to have to be potassium, right? And we've got a negative 2 ion, and the negative 2 is going to be, it's got to be the sulfate, so this has to be what I have. I can also look that I should have 2 positives for every 1 negative ion. 1, 2, 3, 4, 5, 6, 7, 8 positives and 4 negatives, so that works in that way as well.